What's up, everybody?
Hello.
How's it going? I don't think I've seen you here. Is it Jerome?
Correct. And
Nice.
no, I just popped into this one. I was just figure I'll pop into the next one or so.
Right on. Yeah, I normally we've got about 8 to 10 people. Although with Christmas being on Friday, I'm wondering if people have kind of checked out for the week.
Yeah. Are you guys? Will you be rebooting this later? To start from the beginning, because I'm like behind by 4.
Well, we're going to be we've got all the recordings on the vSchool blog site, so you'll be able to at least look at like the previous episodes there.
Okay, cool.
But if I'm gonna give people a few more minutes, and if no extra people show up, why don't we can start from wherever, and if I can just kind of help maybe answer some questions you might have about TypeScript or anything.
Thank you.
Sound good?
Yeah, I'm just cracking open a couple of books on it. I ran through a tutorial. Attended well, pre-COVID, I attended a couple of classes on it, or
on TypeScript.
On TypeScript, yeah. There's a New York based group downtown that I had went to with a friend.
Okay.
I haven't been back since, obviously.
Yeah. I can imagine why.
Can't imagine. Don't know. Maybe it must be special.
It's been some weird thing that happened this year.
Yeah. All of New York shut down.
Yeah, man, that's just crazy times.
Yes. Are you using TypeScript for something? I guess React based or just
Yeah, so I've used it in my previous job. It was React TypeScript. My current job, I'm using it in Angular.
Cool. How do you find vSchool?
Well, I used to teach at vSchool. I taught there for a couple years, and so it's been about a couple years since I left, but I'm kind of informally a tech advisor for them. So I like to still be kind of involved with the community. So this is one way I do it, is just by hosting these little sessions.
Cool.
Yeah.
Something I'm looking at currently.
Say that again.
Something I'm looking at currently.
Oh, cool. Yeah. I had a great experience with them. I mean, I was a student prior to, this was in, let's see here. This would have been 2017 is when I graduated from the program. And then afterwards, I worked there as a TA and then kind of worked my way up to the lead instructor role. I kind of just became absorbed in all this stuff. To me, it's really fascinating. I mean, I love coding. I'm glad I found it. And yeah, it's a really good skill set. vSchool's curriculum is really good. I mean, I did what I went there to do. I became a professional software engineer. So, it's certainly possible.
Yeah.
So, and I know all the guys there. So if you have any questions, I'd be happy to answer anything. Or I could at least point you to some people.
Well, I just recently talked to the person who I guess does the initial questioning.
Oh, okay. Was it? I totally just spaced his name.
It was a woman,
Jen? No.
possibly. Yeah, I could look up the actual appointment to find out who it was, but let's just see here.
Was it? It wouldn't have been. Was
Debbie.
Debbie? Okay, yeah. Yeah, Debbie's fantastic.
Mm-hmm.
Cool. So, are you? So, you said you were interested in TypeScript and going to V school potentially. So, have you done any prior coding at all, or?
Yeah, that's my current job. I'm just trying
Okay.
to level up my knowledge in both React and TypeScript. I'm
Mm-hmm.
mostly an old school front end guy, so leaving some wanting needs for leveling up.
Okay. Cool. Yeah. Yeah. I'm pretty fluent, I guess, in React, so I can also answer any React questions as well. I love React. I think it's a really cool framework. So.
And I remember when it got started. So
Yeah, like it didn't come out very long ago, relatively
what do you
speaking.
consider very long ago?
Yeah, it's pretty cool.
What do you consider very long ago?
Well, I guess like React was, so when um, it was becoming popular right as I was finishing up my boot camp. At the time, that was in 2017. React, I mean, it had been around for, I don't remember what year it actually was like released, but it was starting to become like people started to talk about it right as I was finishing up V school. And at the time they were teaching Angular, so I didn't actually learn React until a little bit later on.
Yeah, when they stopped doing it. Yes, I had heard about it a long time ago. Long as compared to your long.
Yeah.
Before I had started my current position, which was 6 years ago. So,
Okay. Yeah. What year did React like actually get released? Do you know?
Actually get really they were at zero when I was looking at it, and it was mostly for making an app using JavaScript in phones.
Okay.
So you could easily spit out something that's what excited me, because I thought, oh, it'll auto compile and generate it into something else. Yeah, that sounds really cool. But no one was using it. So
Right.
I was like, oh, that sounds really cool, but I can't use it. So it doesn't really didn't really matter. Right.
Right.
So yeah.
Nice. That's like the OG.
Yeah. Yeah. I mean, when you see ideas about even Angular back then was like it was like, oh, that's nice to have, but still.
Yeah, like the concept was like it was hard to imagine how useful it would actually be, and how
Right. Well, we
prevalent.
still had a lot of browser issues and a lot of stuff that we
Right.
had to deal with.
Right.
So
For sure.
now I'm catching up, because you hold
Right on.
it held back, and all of a sudden you want to switch over.
Yeah. It's amazing. Just even like 3 years, how much
Right.
things have changed. It's insane.
Mm-hmm.
Like I can't even keep up with it. It's crazy.
And then TypeScript on top of it. So you add
Right. Yeah.
oh
Yeah.
no, we're gonna go
Constantly.
functional. Let's go, instead of going functional, no, let's go. Just drive a straight line, people. Just drive a straight line.
Yep. Cool. Well, it looks like we got one other person. Welcome. I'm not sure. I'm not sure if you were at the last one either. So since we got a nice small group today, I want to make this as useful and informative as possible. So I want to maybe let you guys kind of lead this. So what questions can I maybe ask or answer just TypeScript related or not, I'd be happy to kind of try to cater this to you guys to see what can help the best. So do you guys have any like questions for me specifically? And we'll kind of start there.
You don't have to deviate from me at all. So you just tell me where you want to be at. I can definitely absorb a lot.
Okay. What about you, Jay? I'm sorry if I mispronounce your name. Is it Shaith? Oh, I think you're muted.
Yeah, it's Chet.
Oh, Jay. All right, cool. Were you here last time? I don't.
No, I was not here.
Okay, cool. Is this your first time? I don't recognize your name.
Yes, this is my first time.
Oh, okay, cool. Well, this so technically this is part 4 in TypeScript, but none of the regulars that have been coming are here today, probably because of the holidays. So why don't we start from square one? I'll give you guys a quick kind of intro. Does that sound good?
Yeah. So
Okay.
personally, I have been a software developer, embedded systems for the last 10-15 years.
Okay.
So, but I'm not like a pure software. I'm more like an electrical engineering type of guy.
Okay. Cool. So, so it sounds like both of you are experienced developers, probably even more than I am. I've only been a professional engineer for the last couple of years, so I probably have a lot to learn from you guys, which is really cool. But it sounds like both of you are kind of new to TypeScript, so I'll see if I can help kind of fill some gaps with TypeScript. Sound good?
Yeah, sounds good.
Sounds
All
great.
right. Awesome. So let's start from the top. So, all right. I'll share my screen.
Are you in Mountain Time? Is that what it is?
Yeah. I'm located in Salt Lake City, Utah.
Okay. So I think I see you on the Slack.
Mm-hmm. Yep. I'm in the vSchool Slack channel. Technically not an employee anymore, but I'm still involved in just helping out people. I really love teaching, so it's one thing I miss ever since I became a developer. All right, can you guys see this okay?
Yes.
All right. Okay, so now maybe you guys have looked at the docs before, I'm not sure, but they're really good. So the first place I tell people to go to is in the Get Started section. These are all really, really great. I spent a lot of time when I was first learning TypeScript, just kind of reading over this stuff. Really helpful. Their handbook is really fantastic. So I highly recommend just kind of going through this and then obviously just building your own little projects to get used to this stuff. So, but what's really cool about their docs is that they've got this section called Playground. We're going to spend a little time in here today to kind of go over some things. It's just cool because it does kind of an auto, right? It will compile everything for you. It's just a nice little playground environment that we'll test around or give it a little go over some concepts. So okay, so some first things about TypeScript is that there's two very important kind of fundamental ideas. First one is it is a superset of JavaScript, which simply means that any JavaScript syntax is also valid TypeScript syntax. So there's no compatibility issues with JavaScript and TypeScript. If you were to write a JavaScript program and then change it to a .ts file, the syntax will be valid. Now, there are obviously benefits to using TypeScript. So using plain JavaScript wouldn't really serve you very well, or it wouldn't serve you any better by converting it just to a TypeScript file. However, because TypeScript is a superset, that means that there are some syntax things that you can use in TypeScript that obviously will not work in JavaScript. And I'm going to go over some of those things in a second. So that's the first thing, is it's a superset. So all valid JavaScript is also valid TypeScript. Second of all, it is a typed language. So, and it's, which I'm sure you guys know what a typed language is, but in with JavaScript, it just means that it is a type checking compile time language. So all the types are checked at compile time, just like in other strongly typed languages. There are some very interesting differences between TypeScript and some other languages, which are really cool. First of all, it still uses JavaScript's prototypical inheritance. It's not truly it's not a fundamentally different language than JavaScript, other than it just provides type checking. But the way that it does type checking is important. So it is a structurally typed language. So what that means is that the shape or the structure of a value is what determines its type, as opposed to a named type system where, so for example, let's say that I have a type called, I'm going to define an interface, which is just an object essentially, or it defines the shape of an object in JavaScript. So suppose I have an interface, and we'll call it person. Person has a name, and it's a string. Okay. Now, when I say that it is a structurally typed language, what I mean is it is the shape that determines whether a type is valid or not. So that means that it doesn't matter what name a type has necessarily, like what alias you give it. If they are shaped the same, then they are considered the same type. So, for example, let's say I have some function called print name. Okay, and it takes a person as an argument, and this person, I'm going to say, is of the type person. Okay, well, and it's going to return person.name, or sorry, I'm going to console log it because we are printing. All right, so now, right now, this function is expecting that I give it an argument, which is an object, which is shaped like a person. That is why I'm getting an error here. It says expected 1 argument, but got 0. It needs at least 1. So let's go ahead and pass in an object. Okay, I'm going to do name and then Ben. What I want to point out here is that this is not creating an error. This could be a problem if this was not a structural typed language. Because notice this value here that I'm putting, I'm not defining it as a type. This is just an object literal. It's just kind of a value that I created out of thin air. I didn't actually explicitly give it a type. However, the compiler is still accepting it. So the fact that the shape of this object happens to match this interface here is why, or this is an example of how this is a structurally typed language. Now, I, of course, could define person as a person, and I could simply say that you are this value. And this will, of course, work as well. I'm not getting any compile time errors. It runs just fine. Okay, let's see what happens if I do something else. I don't know. Let's say we do a user, and let's say we say you're a string. Okay. Let's see what happens if I do this. Okay, notice I'm defining user as an object that has a property called name, which is a string. And I'm passing it into this function. Well, it's expecting a person type, but notice I'm giving it a user type. But the fact that they have the same shape is what TypeScript is expecting. So that is just a subtle part of the language that is very important to kind of understand from the outset. Do you guys have any questions about that so far?
No.
Cool. Makes sense?
Yes.
All right. All right. So let's talk about just some of the basic types. So I did an interface here just to show you an example of the structuralness of TypeScript, but interface is actually a slightly more complicated type. Let's start from the very basics. So in TypeScript, things can be defined as several very basic types. So just like in JavaScript, where you've got undefined, null, number, string, Boolean, etc. Symbol, some other, is that everything? That's all the important ones. These, of course, are perfectly fine TypeScript types. So for example, if I define some null value as being null, you can't be anything other than null. Same as undefined value. If I say you're undefined, then you can't be anything other than undefined. If I try to make you 10, not going to work. 10 is not assignable to type undefined. So this error I got very familiar with as I was learning TypeScript, and so will you guys. This is probably the most common error you'll find. It's just when you try to assign a value to a value to a variable or put it into a function or whatever that is an invalid type. All right, so that's undefined. Okay, cool. Of course, there are other things like I can say const x is a number. There you go. This is a little redundant. However, what I'm doing, usually if you're defining a constant as a value, then it's a little redundant to have to do this. But this is the syntax for defining types. It's just the variable name followed by a colon and then the type. And this type can be any type. So whether it's an interface or an alias or number, undefined, whatever, that can be anything. All right, and then let's look at some other ones. So arrays, of course, are an important data type, and those are defined in a similar way. So suppose I have numbers, and I want that to be equal to an array of numbers. Notice when I just define an empty array, it will kind of default to any. And usually if you see any, that's usually a sign that you need to be more specific. So because I've just defined this empty array, there's an implicit meaning behind that, which is this is an empty array, but it could have anything in it. There's nothing stopping me from pushing strings, Booleans, objects, other arrays into this array. So, because this is TypeScript, we want to enforce types as much as possible. So if I want to make sure that this is an array of numbers and not just an array of wildcards, I'm going to define it this way. It's an array of numbers, so I'm going to do that. Now, if I try to push anything that's not a number into this array, I'm going to get that friendly error again. So that can only be, I can only put numbers in there. It's that simple. Okay, objects are defined using interfaces, which I briefly did earlier, but to give you an example one more time, objects are simply interfaces. There are other ways to do objects. I may or may not get into that today, but the most basic and simple way of defining the type for an object is to use an interface, and it's as simple as just giving it properties. String, email, string. I don't know. Admin is maybe a Boolean. Maybe of friends, which are other users. And maybe, I don't know, just use some arbitrary values. Okay, cool. There are ways of defining optional properties, which you can do as with the question mark syntax. So that will allow me to define objects that are users with or without the admin property present. So that's how you do that. Okay, any questions about arrays or objects? These are the most, well, besides functions, which we'll get to in a second, these are the kind of the two more confusing ones, I think.
I'm still good.
Cool, cool, cool. All right, let's look at the last one. Oh, go ahead.
Yeah, me too. I'm good.
All right, cool. And if this is too basic, just let me know. So, all right. So finally, functions. Functions are probably the hardest, followed by arrays and objects. So with functions, now because JavaScript has so many different ways of writing functions, there's like an annoyingly high amount of ways you can write functions. There's a lot of ways to do this, which is why it's confusing. But with ES6 and arrow syntax becoming so common, unless you have a specific need to use the function declaration style, because of a this context or whatever, the most common you'll see is something like this, where you have, so let me think of the best way. Okay, so when you're defining a function, usually the easiest way to define the type for a function is to define it in line. So that simply means to define the types of parameters it has, as well as the type that defines its return value. So if I have a sum function, then I'm going to want to define its individual parameters as perhaps a number. So again, there's that colon syntax. It's pretty straightforward. And then the return value is defined prior to the arrow. And if this were a function declaration, it would be similar. So X is a number, Y is a number, and then you return a number. So again, it would be the same or a similar looking syntax. This just has the arrow. Okay, so obviously right now, function is giving me that it's giving me an error that you'll become quite acquainted with. Function whose declared type is not void or any must return a value. So again, this is one of the benefits of typed language. It's telling us that, hey, you said this returns a number, so you should return a number. So let's do that. So we'll do X plus Y, and then our error goes away. So one of the cool things about TypeScript is how it's able to kind of infer the types of values. So notice I didn't have to do anything like this. And then return output. It's perfectly acceptable. It's perfectly fine syntax. A little verbose, but you know, it does what it says it's doing. But this is redundant because TypeScript, because it knows that those are numbers to begin with, and because it knows what operation this is, it can then infer that this value is a number. So it's unnecessary to really define the type of the output of this operation. So anytime you're using an operator on any values that have already been typed, it knows it can infer the type. And it can also infer the types of functions as well, or the return values of functions, which is also nice. For example, let's say I have a number Z and I want it to be equal to the sum of 2 and 2. Well, it now knows that Z is a number. It's not necessary to do this because it has already been inferred. And if I try to use Z in a place where numbers are not prohibited, then TypeScript will throw a compile time error. So that was kind of one of the biggest challenges for me, was learning kind of when I needed to type things, when I didn't. At first, my code was like filled with types, and as I got better, I kind of realized how I could keep my code, you know, thin and slim while still being strongly typed in a useful and efficient way, or effective way anyways. So that's a function. There are other ways of defining a function that I want to go over because they are important. So you can define a function as a type, and this is where I want to introduce the type alias. We're not going to get too far into type aliases because there's a lot of cool stuff you can do with it. But again, we'll start with some basics. So notice that you can imagine if let's say I'm building a math library that just does purely mathematical operations. You could maybe argue that it's a little redundant to have to write number every single time. Like maybe I read a multiplication function, a division function. All of these functions have the same shape, right? Kind of like how the user and the person interface had created before. They both had a name. They were both strings. They have the same shape. So it could be useful to define a function type that is more than just the explicit declaration of its parameters and return value in the actual definition of the function. Sometimes it can be beneficial to define a function this way, to say, using the type alias. So I'll call this a math operation. And now I can define my type using the type alias syntax. And defining the type for a function is very nice. It's very simple. So X is a number. Again, this is all the same. But then I can just use the arrow and then do this like this. So this right here is basically a type schema for a function. So if I bring this up, I can now, instead of explicitly doing X and Y in here, I can now just say, hey, you're a math operation. And I will have the same, I will have the same functionality as before. So this can be useful for if I want to do a divide. Again, I can just say you're a math operation, X and Y, and you return X divided by Y. So this is a nice way of writing some cleaner looking code. You can also do it with an interface if you want. So you can also do stuff like, suppose I do interface math operation. Now I can say X, Y, again, X, Y number, and then the syntax is slightly different with a colon instead of an arrow. That. So that also will work. There are some subtle differences between doing it this way and this way, which I won't go into today, but now you know how to write function type definitions. There's several ways, either inline, with an interface, or with a type alias. So any questions so far?
No, no, not at all. Thank you, though.
Yep. So, cool, sounds good. Alrighty, so let's see here. All right, so those are some of the basic TypeScript values, types or whatever. However, there are a few other things which are kind of cool in JavaScript or in TypeScript that I want to introduce. So there is the type void, there is the type, and there's the type never, which is also kind of interesting. So, and they're similar, but not identical. So void is kind of useful for a for defining the return value of functions that don't really return anything, because obviously the default return value of a function in JavaScript is undefined. So if you don't provide a return statement, it just automatically returns undefined. So you can use the type void to represent that. So for example, print text. Here's our text, it's a string, and this will return void, and we'll just say console log text. Okay, so there we go. Okay. So print text. There's no return value. There's void. All right, cool. Returning undefined would also be the same thing as void. Let's see what happens if I try to return null. We would then have a problem because null is not the same as void. So I think that's a common point of confusion, is that null and void are not the same type. Neither is undefined in void, but void encompasses undefined. There is the keyword never, which is even more empty than void. While void contains undefined, never is the type that literally means it can never happen. So this is used for when you have the possibility of throwing an error, for example. So suppose that suppose this function. Well, let's think of a here's an example. So let's look at this divide function, for example. I'm gonna clean this up a little bit. Okay, so let's look at this divide function again. So we already know that, okay, x is number, y is number, and it returns a number. Okay, well, we can obviously think about a time when dividing by 0 may not return a number. Now, if I were to return x divided by y in this case, and I were to say divide 5 and 0, this is, while not mathematically allowed, it's still processed logically according to JavaScript's rules. This isn't an error per se. We get the infinity data type, which may, depending on your use case, maybe you want it, maybe you don't want it. Let's say, for the sake of argument, that we don't want to divide by 0 and we want to throw an error, like we don't want this to even be allowed. So we could have this idea, or we can have this, we can say that this return value is either number or never. So this also introduces a concept of the, it's called the, I totally just spaced the name of this thing. I use it every day and I just forgot what it was called. It's not the join. It'll come to me. It'll come to me. It's like or in JavaScript. So what this is saying is our divide function is going to either return number or never. Okay, so never is what we want to use when we know that this function is never going to return anything. So throwing an error. So for example, if y is equal to 0, then we'll throw an error that says, cannot divide by 0. So this would be a case where the never data type is useful. I've used it many times, and it's very nice to have. Does that make sense?
Yeah.
Cool. This is gonna bug me. I need to remember what that's called. It's called an intersection. It's called an intersection. Okay. Okay, so while we're on this subject of the intersection, this introduces two very cool concepts in TypeScript. The union and the intersection. So they're both fairly intuitive, although they can be a little bit tricky when you start dealing with more complicated types. But let's start with the basics. So there's the union type, which is the and symbol, and then there's the or, the bar, which is the intersection. Okay. Now, basically these allow you to construct types from existing types. Okay, so and like I said earlier, TypeScript is a structurally typed language. So that means that as long as the shape of a type matches the shape of another type, they're effectively seen as the same type. So these can be used to construct some pretty interesting types. And on that note too, because because TypeScript is structural, it also means that there's a hierarchy. Okay, so for example, if I have a Boolean value, so let's say that X, or let's call this, I don't know, is admin. Let's say it's a variable. Okay, let's look at this property. Okay, this is a Boolean value, and let's do let, so we're able to define this type. So I'm going to then say is admin is equal to math.random. Actually, let me use a, I'm going to call this coin flip result. This will make a little more sense. So I'm going to say, okay, coin flip result 0.5. Okay, we know that that's going to be true or false. So we're allowed to define, or we're allowed to define this type with that value. Okay, well, let's do this. Instead of defining as a Boolean value, let's see what happens if we define it as a aggregate of, or an intersection between two types. That works. And in fact, true or false is the exact same thing as Boolean. So there's a hierarchy of types. Now, of course, if I only said that this is true, we have a problem, because the most specific type of value that we can expect from this expression is a Boolean. We can't guarantee that that's going to be true. So therefore, Boolean is not assignable to type true. So we have to do that. That was one thing I was really confused about TypeScript at first, is that true and false, while in JavaScript, they are primitive data types, or they're actually primitive values, like true is a value. In TypeScript, it is both. It can be treated as both a value and as a type. So I kind of had to, that took me a bit to realize. And it's also true that they can be numbers. Like numbers are also technically types in TypeScript, which is kind of weird. So like, for example, 0, while it's a value, it's being used as a type here. So if I try to say 0 equals anything that's other than 0, 1 is not assignable to type 0. So 0 is just the absolutely most specific type of number you could possibly have, right? Number is a very broad category of possible values. 0 is a very specific type. So there you go. So that's the intersection. Okay, there's the union, which you probably already know what this does. It allows you to construct types out of the combination of two types. So, for example, I can say, so first of all, this would not work with that, because true and false, while this is a perfectly valid, the syntax is perfectly valid, given the fact that I am just simply using two values separated by a union. This is perfectly fine syntax, but that type is never, it's a mathematical impossibility. You can't be true and false at the same time. So that actually compiles to never, which is kind of cool that TypeScript is able to do that. So, and is more useful for when we want to combine types that already exist. So For example, let's say, and it's really useful for objects, especially when you're doing functional programming and you're doing like function composition. So, for example, let's say I have an interface called with ID, and it's just an ID property. It's a string. Oh, I spelled that wrong. Okay, and then let's say I have some interface called, I don't know, user. Okay, again, back to our name. Okay, what we can do is we can create perhaps a database user, like this is our entity. This is our like, the thing that describes this piece of information. But then we also wanted to define it in the context of a database. So perhaps it has an ID now. So we can use the union operator to construct a type called, we'll call it DB user, database user. And we can just say, hey, you are a user and a with ID. So now when I try to make a DB user, if I say that you are a DB user, then not only do you have to have a name, but you also have to have an ID. So this is really cool. There are some subtle things that happen with the intersection and the union. So with a union, it's a exclusive and, which just means that it will only combine, or sorry, I said that wrong. It will have all the properties of each type. Okay, and if you have two types that are like invalid, or let's say, for example, I have a type optional, and I have a thing called name, and I say, oh, and then I have type required, and here I say, okay, you have to be a name. Oops. Oh, sorry, I meant to define these as interfaces. Oh, required is already existing. Sorry. Okay, so now if I try to combine these, let's see what happens. So it's basically going to do the most, the broadest, it will do the most broad type that works with both of those. So this one's optional, that one is required. So if I try to have, some object and it's combined, and now it's saying that it's required. So, and that's because this is the broadest, right? Maybe broadest isn't the right word. This is the most, like this has the most power, I guess. Whereas this could be string or undefined, this has to be a string. So it's going to do whatever is the most enforceable. So that's why it's required that this has a name property. Okay, if I use the or operator here though, let's look at what happens. Okay, again, I'm going to do this. And notice there's no error this time. And that's because when you have a type that is the intersection of two interfaces or objects, then it will simply, what's the word? My words are not working today. What's that word? Oh, it will distribute. It will distribute the values. So in this case, because this is string or undefined effectively, and this is just string, well, it's going to distribute name or undefined across each type. So we now get name, or we now get optional or required, which means string or undefined. So it is perfectly fine to now have this be undefined or a string. Whereas if it was a combination, we now are forced to use the part that's required. One other point I want to make about the intersection is when you have two types that are very different. So suppose let's use an example where we have two objects that share one property, but they don't share any other properties. Okay, so we'll call this, we'll just say animal, I guess. And we'll have a name. Okay, cool. Now let's do fish, and fish has a name, but then it also has can swim. Kind of arbitrary, but it'll work. Okay, dog name, run, and then is mammal, which of course. Okay, so fish and dog are two different interfaces that only share some subset of properties. So let's see what happens if I try to define a, actually, you know what? I don't know why I did animal. I didn't really need that for this example. Let's say that, oh, I actually know why. I meant to do this, right? Type animal is equal to dog or fish. Okay. So suppose I have some property that can be an animal. Okay, now the thing is because I'm using the intersection operator, that means that it's going to enforce the minimum required properties of one of them. Okay, it has to know which one it is to be able to fully enforce all the types, right? Because we're saying is mammals required for dogs, but can swim is required for fish. And this isn't on the fish property, and this one is not on the dog property. So by defining something as an animal, we kind of have a conundrum. So here's, name, which is fine for both of them, but now we have a problem where now it's saying that is mammal is missing in type dog. Well, it's defaulting to saying, okay, you should be a dog, but suppose this is a fish. Well, I could define it as this, and now we have no problem. Okay, but then we could also do is mammal, and now we have no problem. The problem is when you have functions or when you have a function that takes the super type as an argument, such as in this case animal. So we'll call it process animal. This is totally arbitrary, but I think it'll get the point across. So let me get rid of that one. Okay, so here we go. We've got our animal, and we know that this is an animal. And the thing is I don't know which one that is, so I can't simply just say animal dot is mammal, right? All it knows is that animals all have a name property, but there's nothing based off this property to know whether it has an is mammal property or it can swim. Something has to happen logically that tells the TypeScript compiler which one it is. So one way to do it is to do something like this. If, and then we can ask to see if a property is available. If is mammal is in animal, then we can console log animal dot, and now it recognizes the property. It doesn't give us a compile error anymore. And what's also really cool is because we have now determined after this if statement that animal is of the dog persuasion, if that exists. Well, the only other option now, because this is an intersection between two types, it now knows that the only remaining possibility is can swim. And it doesn't give me a compile time error. So that's kind of the basics of TypeScript to start with. Do you have any questions?
Oh yeah, one thing I wanted to ask is what is the difference between TypeScript and JavaScript? Like
Difference between them?
where is one used over the other?
So TypeScript is based on JavaScript. So JavaScript is all JavaScript is valid TypeScript syntax. The only difference really is that TypeScript uses a compile time type checker to compile to JavaScript. So like if you look at this, this is the compiled code from this.
Right. So people generally program in JavaScript or TypeScript, like I mean for job applications outside and all of that. I just wanted to have an
Yeah, I
idea.
mean, yeah, JavaScript is, I mean, TypeScript is pretty new. It only came out a few years ago, to my knowledge.
I see.
Yeah, so it's really, I've found it to be incredibly useful. In fact, even when on my own projects at home and stuff, like I primarily do TypeScript because it's so much easier to use. It's so much more friendly because you're not having to, you basically, you don't find out about lots of kinds of errors until runtime in JavaScript, whereas in TypeScript, most of those errors are found before you have to run it.
I see.
Yeah.
So is it like you program in TypeScript and then you transfer it to the whatever program you have in Java or something, or it's like you just uh, write in TypeScript alone and compile and then you go forward. How does this work?
Yeah. So like usually what you do is you'll have so I'll give you an example. So let's do this one. I think I've already used this one. this is not the one I want to use, sorry. TS demo, I think this is what I wanted. Nope. Let's do it from scratch. All right, so let's do a so normally what you do, so this will be a simplified example, but it's very straightforward. Basically, you install TypeScript. Having a linter is also nice as well. And then okay, so normally what you do, you've got your source code, right? Here's your TypeScript file. So this is where I'm going to write my TypeScript syntax. And then what I want to do is I need to tell the compiler what to do with this TypeScript code. So I've been using this playground here and it's already pre-configured, but if I were doing this in the wild, I would first of all create what's called a TypeScript config file. And it looks like this. You just say, just initiate it using the CLI. It'll create a nice little tsconfig here. So here are just the defaults. So this kind of tells us, okay, what do you want the compiled code to look like? What module system do you want to use? There's a few other things, you know, if we're developing, I'd want to have source maps. There's some other specific things you can do. The most important one though is this outer. This says, hey, where do you want all the output files to live? So it's common to call it dist for distribution. And then we also want to say, hey, I want, oops, not files. I want to include. So this tells us all the places where our input files should live. So I want to do it in source, so I'll do it over here. So now I can just start coding, and then when I'm ready, I can just compile it, and then whatever my compiled code is, that's what I'll use in my application. So suppose I have my document. Here's my HTML. Okay, and then, you know, here's maybe my H1. Okay, so I'll go over here and I'll say const H1 and I'll grab the, or actually this is no idea. I'll just query selector, the first H1 that it finds. Then I'll just say H1.inner text is equal to world. I have to make sure that this is actually an HTML header element. Cool. So here's my very, very simple TypeScript application. Over here, I'm going to want to import my. I'm going to want to reference my script. Now I can't do source index because this is TypeScript and the browser doesn't understand TypeScript. So I'm going to want to use my output code, which is going to be index.js. So if I run this, we won't see anything. It's blank because first of all, we haven't compiled the code yet. So we're going to see this, you know, not found. It doesn't know where that is. So we gotta generate it. So we'll just use my the TypeScript CLI that comes built in with this library. Go ahead and run it. It'll read my tsconfig and it will produce my output. And there it is right there. And notice it doesn't look that much different than my code here, but There it is. And now if I go to my code, now it shows up. So that's a overly simplified example, but that gives you an idea.
Yeah, I think I get it now. So this is used to import into a HTML, right? And then you see that in that web page.
You can use it in Node. It doesn't have to be a browser. It can be anything.
Okay. Oh, okay.
Yeah, TypeScript is completely separate from its implementation. All it does is whatever JavaScript, all it does is compile TypeScript into JavaScript. That's all it does.
Oh, okay.
So so it doesn't matter what environment that code is being used in, whether it's Node or a browser, it doesn't matter. It's just however you want to use it.
Oh, the advantage is you can get some errors right away, defined errors, but logical or program errors when you run with it. Right?
Sorry, you cut out. Say that again.
The advantage is that you can get defined errors, like some standard errors right away when you go, but the logical and programming errors you only get when you run.
Yeah. Like you can get you can solve a lot of runtime problems by just seeing them before it runs. Or sorry, it'll catch all
Right.
of your type errors before it runs.
Right.
Yeah.
Right. Yeah. Okay.
Yeah. Like for example, here, if I try to tell you that you're 10, it's going to yell at me because you can't assign a number to something that's supposed to be a string.
Right.
Yeah. And this is a simple example, but it's really awesome when you have a huge application and it's not exactly obvious
Right.
what type this may or may not be. So having it tell you right then is pretty awesome. It's pretty powerful.
Right.
Yep. So yeah, you have all of the basic tools to kind of get started. The best place I would recommend to go is just on the TypeScript documentation. Just read through the handbook, and then when you kind of feel comfortable, just try your hand at it, try to get it working. And if you're interested, I did this a few weeks ago, but I created a repository that you can clone down that basically has TypeScript set up. Where is it? It's one of these, TS Playground. This one, yeah, this one. So this one right here, I'll send the link in the chat. So if you want, you can clone that down. Basically, it's just it's a pre-made TypeScript setup. It's got the linter and the tsconfig setup. It's also got jest in there, so you can use this file, just like play around, get used to it. If you go here, you can write functions. I've already got a few here written, just so you can kind of see the kinds of things that you can do in TypeScript. And you can then, of course, add more here and then test them in the test file. Everything is already set up, so you can just kind of get up and running with this. So.
Oh yeah, that's really nice. Yeah.
Yep.
That
So
really helps a lot. Yeah.
Yeah. So this is a good place to kind of get started. So yeah, that's all I got today. I hope that was helpful.
Oh yeah, it was pretty good. Yeah.
Sweet.
Going through all the until the video and all that I'd forgotten for a while. It's good to go back and brush it up. Yeah. Yeah.
Cool. Well, yeah, thanks for coming. Next time we'll be there's two more, I believe, TypeScript episodes. Every week is a new topic. I decided to do TypeScript over like a longer period just because it's pretty. There's a lot to it, so I wanted to spread it out over several sessions. But so we're going to finish up TypeScript over the next 2 weeks, and then we'll be going into some other new topics. But I do this every week on Monday at 4, so you're always welcome to join.
Oh, okay, thanks. And one question I had is, do companies use TypeScript, or it is something like JIT, which research institutes and
Uh,
students use?
we use TypeScript.
Oh, okay.
Yep.
Okay. It's the first time I'm hearing about TypeScript, so that's
Okay.
why I had
Yeah,
this question.
it's becoming like pretty standard. I've found in both of my jobs as a web developer. I've used TypeScript. I mean, I've used only TypeScript the last 2 years.
Oh,
I
okay.
haven't even used JavaScript, at
I
least
see.
not directly, anyways.
Okay. Okay.
Yeah.
Yeah. Yeah.
So yeah, there you go.
Oh, thanks a lot. Yeah.
Yeah, you're welcome. You have a good one.
You too.
All right, see ya.
See.
Oh, son of a motherfucker.